Welcome to ETM 260 Computer Aided Design. This is Lecture 6, Advanced Modeling Tools, Part 1. This video is supplemented with the given points of PowerPoint. This lecture will introduce you to new techniques in order to create more complex objects and designs. In order to start, we're going to open the file for Lecture 6, Part 1. The first feature that we're going to introduce are holes. In order to get to the holes icon, we go into the home menu and click on holes. There are 4 different types of holes that usually are used. They are all under general hole. The ones that we will go through are simple, counterbore, countersunk, and tempered. In order to do them, we're going to start by selecting the point at which the center of the hole is going to be located. So we're going to simply locate this surface, and notice that as soon as you do that, it creates a point. We want that point to be located right at the origin. So what we're going to do is we're going to use constraints. So we're going to go to the geometrical constraints and we're going to make it coincident so that this point is coincident with the origin. Notice that it's selected improperly because I didn't have it automatic. I'm going to undo, select automatic, and then this point goes to the center over here. Once you're happy with the selection of your origin, you're going to finish the sketch. So now that's the center of your hole. As I said, we're going to start with simple holes. Simple holes are done in such a way that it shows you the cut that is done, plus the tooling end part representing how it is done in real life. So we're going to start with the diameter. I'm just going to make it a little bit smaller so we could see it. And then we're going to have a depth of 50. Notice by default, the Boolean operation is subtract. We're going to say OK. So notice that it looks like a hole, and to verify that it actually looks like a tool hole, we're gonna change the rendering, and we're gonna go into wireframe with hidden edges. I'm sorry, with a static wireframe. And so notice if we center it and we set it from this front view, notice that it has a cut over here to indicate that it is done with a hole feature. To see the difference, how an extrusion is different from a hole feature, we're going to open the part 1A. In this part, I have already done an extrusion and a simple hole, as you could see it from the part navigator. To see the differences, once again, we're going to go into a static wireframe, and we're going to rotate it to see it from the front view. Notice that the first part is done using the extrusion, and then it simply looks as a rectangle side view. However, as a simple hole, not only has the extrusion, but once again it shows you the tip of the tool that creates that particular hole. So whenever you're doing your application, depending on what the design calls for, you choose whether you're doing an extrusion or whether you're doing a hole. If your hole is a through hole, meaning that it goes all the way to the end, it does not make a difference whether you do an extrusion or a hole feature. Now let's go back to the previous part. We click over here in the window, and we're going to make it solid again so we could see it. And we're going to rotate it. And we're going to change the simple hole so that we could look at the other type of holes that are available. We're going to double click. And then we're going to go, instead of simple hole, we're going to go into counterbore. Counterbore is created by doing a bigger hole over here in the top, and then a smaller hole going through a lower depth. We're going to start with a C-board, which is the bigger diameter, and a diameter for the smaller hole. Always note that the diameter that you have at the bottom has to be smaller than the C-board. So we're gonna do, let's see, 15 with a depth of 20, and then we're gonna have a diameter of 10, and then in this case, instead of having a value, we're gonna go through all. So notice that it goes through the whole body. And once again, we go this way, and then we could see the contour board. We go to a static wireframe, and notice that we have the contour board. We're gonna change that contour board into a contour sunk. Now we're gonna do the process for a contour sunk. They're very similar. The only difference is that the upper part has an angle, and this is how the tool is created, with a particular angle in that tool. So we start with an original diameter, so let's see, 15. The contour sunk angle is default 90, but you could change it by varying the value over here. And then once again, you have a diameter, so let's change it to be, let's see, 5. Notice how it changes, and then you could go through the whole body, or a particular depth that you would like to see. And then we say okay. So notice that now we have a contour sunk hole. And the last one we're gonna try is going to be a tamper hole. So notice that is simply an extrusion, a cut that goes from a higher diameter to a smaller diameter for a particular length. So we start with an outer diameter, let's see, 15, and then we have a tamper length that you would like to have. You could go through a whole body, or you could say a value, let's see, 5, and then notice how the hole changes. You can make it a little bit longer, so you could see the variation. So it all depends on what information is provided in your particular design. The next tool we're going to use is a groove. A groove is a cut or an indentation that is done in a cylindrical shape. If you do not have your icon for groove in your Home tab, simply go to the command finder, type groove, and enter. And notice that in mine it's currently hidden, so I'm simply going to show in the Home tab. And now it's here in my tab. So I'm gonna click groove, and groove, it has 3 different choices: rectangular, bold end, and U-groove. The difference between them is the cross-sectional shape that is done by the tool. If it's rectangular, that means that the angle of the tool is going to be 90 degrees. If it's a bold end, it means that it's completely circular. And U-groove is a combination between rectangular and bold, where the corners are basically have fillets in between. So let me show you each one of them. Rectangular. We don't need to put a name to it. Notice that we simply have to follow the directions that are in the bottom left part of an X. So we're gonna set the placement. So we're gonna choose the bigger cylinder on our part. We're gonna put the diameter, which is basically the depth of the indentation that you would like to have. So let's see, we're gonna do 35, and so we could see we're gonna make it a width of 15. Once we do that, notice that it shows us a representation of where the tool that is creating the groove. So now what we have to do is place this tool. So we need to provide a distance. So we're gonna go from the bottom part of the surface to the bottom part of the tool, and we're gonna indicate that we have a distance, let's see, of 20. We say okay, and notice how it's created. So when we have a rectangular groove, so if we put it from the side view or the front view, notice that you have a completely rectangular shape in the groove, 90 degrees at the corners. I'm gonna deactivate this or suppress so we could try the other 2 grooves. Press it. I'm gonna go into groove, and I'm gonna try the bolt end. Once again, we select the cylinder. We're gonna have a groove diameter, so let's say it to be 30, and the diameter of the bolt is 15. Once again, we have now the tool that represents how the groove is going to be created. We select the surface, so I'm going to select the bottom surface. I'm going to rotate this a bit. The bottom surface of this and the bottom surface of the tool. And I'm making it a 20. Once again, if I put it from the front view, now you see that this is a curve, completely circular. The distance that you have here is the bolt diameter, and the distance from here to here is the groove diameter. Now I'm going to try the next groove by suppressing this. I'm going to go through the process, groove, U-groove, select the cylinder. Now the groove diameter will be the distance from here to here. So let's try it again, 30. The width is going to be basically the height, and the corner radius, it will be the little fillets that it will have at the end. So we could use those default values. Once again, the tool is shown, and we're going to select the placement of it. Select from one point to the next, and let's see again, 20. And then let's look at it from the front view. Now notice that you have, it looks like a U, almost like a rectangle, with a groove diameter over here, and now you have fillets on the corners. The next tool we're going to try are slots. Slot is a narrow aperture or a slit for something to be inserted. In order to show you how it's done, we're going to open the second file for lecture 2, part 2. So notice once again that the command is not inside of the home tab, so we're going to insert it. You tap the slot, enter, and then notice that is the bottom part is legacy, meaning that it is part of the previous versions of NX and is being carried out into this new version. So we're going to show it in the home tab. Now notice that it shows up in this part of the menu. You're going to click on it, and we're going to try the rectangular tab. The choices that we had were rectangular, bold end, slot, T-slot, or dovetail. The choices depend on the cross-sectional view of the tool used to create the slot. So let's start with rectangular. First, notice that the instructions are placed at the bottom left corner of NX. The first thing that we're going to use is select the surface where they're going to be done. So we're going to click here, and then we're going to select the orientation reference. So a slot usually has a minor and a major length, and what we want is to be oriented along in a particular direction, so you choose an axis or a line. So notice that it shows you that direction. We're going to make it a little bit bigger, so let's see, 20 and a width of 5. We're going to keep the depth at 5, and then we're going to click OK. So notice this is the slot that we have. By default, this slot is always a rectangle with 2 semicircles at the end. The next step is to be able to place this slot. We're going to use a horizontal dimension. We select a position from your object, and then we're going to select a line that is parallel to that line that you originally selected. Notice that it gives you a dimension, and then you select depending of what information you have. So let's see, we're gonna select 50, and then we're gonna do now a vertical dimension. You choose another value, and the line once again that is parallel to that, and then we're gonna put another dimension. We're gonna click OK, and notice that the slot is created once again by default, and because it's rectangular, it means that the angles that you have between the surface and the tool is 90 degrees. Now let's try some other ones. We're gonna try the U slot. We're gonna use the same surface, but at this time we're gonna use this direction to be the major orientation. We're gonna have a width of, let's see, 10, depth of 5, corner of 5, and let's see, 20 as the length, and it gives us a slot. So once again we have the slot, Now we have to provide a position for it. So we go from value to a line, and notice that it gives us the distance. So let's see, 50. And then we're going to use a vertical, so we use from here to here. And then let's see, 100. And notice if we look a little bit in more detail, notice that it's a U type of slot, because at the bottom it has a fillet rather than a 90-degree corner. Okay, let's try one more. Let's go for the dovetail. So the dovetail, it's a little bit different because the hole that it has in the top is smaller than the hole that it has in the bottom. So let's start. So we go once again, we locate the surface, then an orientation. So let's go that way. So we're going to go for a width, let's see, of 5. We're going to go into that depth, the angle, and then the length that it has, let's see, it's going to be 25. Notice that first it doesn't show much of the difference, but once we finish, we will be able to see the final shape of the dovetail. We're going to provide the location of it, so we go from one line to the other one, and we're going to do 15, and from here to here, and then let's see, we're going to do 70. Once we finish it, notice that when we have a dovetail, well, we did a very small depth. So let's do it a little bit. So if I made a mistake, I made it too little. So we're gonna change the depth so we could actually see it at 5. So now notice what we have. If I do like this, notice that this is how it actually looks in wireframe. As I said, the hole that you have in the top is considerably smaller than what you have at the bottom, and that's basically the property of a dovetail. So these features allow you to create holes that in cross-section from the top are a combination of rectangles and circles with different depths and different cross-sections as you do the depth as one single step. The next feature we're going to use is edge blend. Edge blend is very useful to smooth different corners that you may have on your solid. For example, we're going to start by using edge blend, which is in your home tab. And notice how it works. We simply select a surface and creates a fillet throughout the whole surface. And let's see, in this case we have 5, and then we go equal to 0. So notice that it smooths the whole part. If you notice that you wanted to do it for the whole upper part, simply double click on the edge blend and select more of the lines attached to it. For example, if you want to create a corner, notice that it does it automatically. Go this way and that way. And doing the process this way, notice that it creates fillets all around as one single step. And next also allows you to do blends with different radius. To do so, do it like this. You select the edge, and then when the menus that you have over here, you're gonna use variable radius, and then you're gonna select points that you're going to have. Either you could add the points manually or have them inferred. For example, you could do click on the points, then you go 1, example, 2, and 3 points. And each one of the points, so when you go, for example, to the first point, we start with 3. The second point, for example, could have a radius of 5. The second point could have a radius of 8. This one could have a radius of 4. And notice that if each one of the points has a different radius, then you will be able to create an edge blend that has different radius at each position. And then you could control where those position of those points are going to be based on your particular design. The next feature that is important to learn is called chamfers. Chamfers, instead of creating a smooth surface, what it creates is a angle cut in that edge. So I'm going to suppress this edge blend so I could show you. Chamfer is over here in the top, and then notice that we could select one edge, and you could do the same process. Notice that it has different choices, but I'm going to show you how to do it for the whole boundary first. So you select the whole part, and notice how it creates a cut that is going to be, in this case, symmetrical all throughout the boundary. If, for example, what you want to do, instead of symmetrical, meaning that it has the same distance from the edge to both sides, you want to do asymmetrical, you could have it that one side, for example, let's see, it's 2 and the other one is 5. So notice that in this case, the distance from one point here is going to be 5, and then the distance from here to here on the other direction is going to be 2. And then the other alternative is to use, instead of values, you could do an offset and an angle. So you could say, for example, you want a distance of 3, and let's see, an angle of 30. The choice of which one of these features to use depends 100% on the type of design that you're trying to complete.